research review. So the well is empty. All my pre-recorded backlog has been put out, but I've got a list of research to review and I'm about to strike out here, so I had to go for something that I know this is going to be great. The last two I tried to hit, I'm not sure on. They're probably not going to make it out. But this one, this is going to rule. Sudi's going to save the day. So we have mutation XSS in a mail application via DOMPurify misconfiguration and CKEditor CDATA parsing bug. This is going to be, I'm going to learn some stuff here because I'm not good at catching those cases where I'm not good at mutation XSS. Like I understand the concept. My mind just doesn't see it. Like I don't have the reps in. All right. Hey everyone. I wanted to write about this bug for quite a long time because it's one of my best XSS findings. The time and effort it took to pull this off was immense. Additionally, this program doesn't allow any form of disclosure, so sadly there will be no screenshots, plus majority of the stuff you see will be in a redacted form. Okay, so immediately, like, there's a program that my mind goes to that has a mail application, and I'm like, is this that mail application? Well, we'll see what I think. So where do we even start? I'll tell you a little about the target. It's a mail application similar to Gmail, but not really popular. I will refer to this target as redacted mail. I was able to find a mutation XSS bug here. If you have been living under rocks and are not familiar with the term mutation XSS, I will give a little introduction for that as well. In short, by sending a crafted mail, I could trigger XSS in the victim's browser when they try to view my mail in their inbox. I feel like the one I'm thinking of renders content in such a way that makes it very tricky to get XSS, so it's probably not that one. Like even if you have HTML injection, it's going to be a pain. It means with this XSS bug, I could read all of the victim's private emails, send any mail to anyone from the victim's account. Usually in mail applications, you'll find they allow you to include HTML in the mail. This is for proper formatting, otherwise all mails would look so ugly in raw text format. Some allow you to include CSS, hyperlinks, and whatnot, but usually all this content gets sanitized. It can be either server-side or client-side or a mix of both. Having them on the client side is beneficial for us because we can look into the source and figure out how the sanitization is happening. For example, Gmail supports the advanced markdown formatting and all through AMP, which is that, I don't know about that. I wish I did. I should know about that. That's why I'm reading this. It has been targeted in the past. You can find some very cool write-ups for these. This one from the legend Michael Benkowski. The write-up is already very detailed, involves DOM clobbering to inject arbitrary scripts into the page. Yeah, I'm sure it probably rules. Second one is this, which involves an HTML parsing quirk from... Style tags are very special content inside of style element is treated as raw text in HTML namespace. No HTML parsing is done in this context, which you can see for the element with ID 1. The only way to break the context for a style element is through a closing style element, which you can see the same example using element with ID 2. Yeah, so that's a trick that gets used for confusing sanitizers, and I wish I was better at it. If you are a careful reader, in my first sentence I used the word HTML namespace. There are three different namespace: HTML, Meth, ML, and SVG. Parsing rules differ across each namespace. For e.g., style is special because it behaves slightly differently on the NS and HTML content. Instead of style is treated as raw text, while in Math, ML, SVG, NS inside the content. Okay. So essentially, in the HTML namespace, the style tag, it's stupid, and it just everything inside of it is text, but in the other two namespaces, it can have elements inside of it that will be parsed as elements. You'll find amateur sanitizers would miss this and treat this as a safe string open style tag, and then closing style tag inside of an ID, but like actually it's not, and then the XSS payload. A relaxed parser would see the anchor element, while it should have treated it as raw content, as the closing style tag inside the attribute value. In the XSS vector 2, they would often skip it, considering it as safe. I've seen server-side sanitizers usually prone to this assumption. Yeah, that's payload worth having. Like, that's a really good example of that. In the AMP bug found by Agami Maulana, you can see his focus was on bypassing the sanitizer using the style element. Google had some checks in place already to avoid letting users include a closing tag instead of a style element context. This was without the last. As soon as you add the closing character, it would flag it. Okay. An explanation around the style element was necessary because my finding relies upon the same quirk in the redacted mail as well. Onto the target now. I started by sending a simple payload to my own email, refreshed the mail, and clicked on it. Yep, just like, why not? Let's try it. No pop-up. Wouldn't be fun if it was that easy, right? Clicking on the broken image, inspect element, I could see the email body content is actually rendered inside a sandbox iframe. This might be the target I'm thinking of. I feel like the target had a strict CSP. I could just... Alright. Well, We'll see what I think about this. I like this, though. And also, if he popped what I'm thinking of, that's really impressive. Is that... because, like, I mean, I'm sure this is really impressive regardless. What am I saying? This is going to be a great bug. There we go. This was an instant bummer. The content is actually sanitized, so some sanitizer was in use. So what are our sandbox policies? Okay, so it has allow same origin, but it doesn't have allow scripts. And it has allow pop. Okay. The values for the sandbox attribute are so limited that you can't have XSS with this. Yep, as it lacks allow scripts. Yep. Directive, you can't execute any type of JavaScript code inside of it. You can't ignore the source attribute value being about blank. That doesn't mean it's of different origin, but the sandbox problem is real and there's no way to break out of it, and it's a total dead end. I think this might have been something I've looked at. The only way to break sandbox iframe is when you have both allow scripts and allow same origin. Directive will allow you to get a reference to the parent window, which is not sandbox, where you can execute any code. Yep. I didn't want to give up hope soon as I was just starting, so I decided to look more maybe any other area. I had no hope actually, but I noticed something very interesting when you click on the reply. Yeah, I think oh man. This rules. I really like this now because I'm pretty sure I've actually. Wow. I might hit up Sudi about a lead I have. The original mail content is copied and added it. Oh no, wait, but this. All right. The original mail content is copied at the end of the reply mail, and you can see clearly how the word testing appeared in the reply mail box. In case of redacted mail, the reply content was actually rendering outside of the sandbox iframe. Yeah, man. The content was still sanitized, but yeah, we made some progress as the content was no longer inside the I wonder if it was like that when I looked at it. Assuming I'm thinking of the same thing. There's still a chance I could get XSS here if I can bypass the sanitizer. It will require the victim to click on the reply option. Still, it seemed promising. Diving into the source to see how they are sanitizing, when a user clicks on an email, the message body of the email is passed to DOMPurify, a state-of-the-art sanitizer. The version used is 3.5.1, which was a bit old at that time, but could be considered totally safe when used with the default configs. There are some custom hooks defined for DOMPurify as well. I mentioned about the reply option where our sanitized content is rendered without sandbox, so after the content is sanitized using DOMPurify, it's passed to reply preview feature, which is using CKEditor. The sanitized HTML gets parsed again by CKEditor here. You can say, for those who don't know, CKEditor has its own inbuilt sanitizer, which is also strict. Yeah, it's weird. Luckily, the use CKEditor version was old, which had a known XSS in it, but there's no public POC available, which would mean I'd need to reverse engineer it. Okay, this is definitely, we're back. We're back. Finally a good write-up. Currently the flow is like this. Mail content, DOMPurify sanitizer with custom hooks, CKEditor with its own sanitizer rendered in page. And is there a CSP? Can we talk about that? I don't know. Pulling off an XSS in this scenario looked very difficult as DOMPurify is super strict around everything. It will sanitize inputs in all cases. Problem was, even if I am able to build the POC for CKEditor, how would I deliver the payload so that it reaches untouched to CKEditor renderer, because DOMPurify will surely remove any possible chance of XSS, no matter what the context is. It can deal with everything before passing the same to CKEditor render. The only possible way to get XSS here would be to find a full DOMPurify bypass, which allows you to pass any HTML to the CKEditor renderer. Jeez. Yeah, I would just give up. That would be my strategy. Not worth it. And it requires the UI of clicking reply. Not worth it. I'm kidding. Earlier I said DOMPurify is very safe. You can trust blindly if you are using it with default configs. Plus, I said that redacted mail is using DOMPurify with some custom hooks. You might ask what these custom hooks are. Here we go. Before sanitize elements, upon sanitize. Yeah, so those are the hooks they support. These hooks allow you to make changes to the sanitized elements / attributes for 3 events: before, after, upon. You can read the docs more to understood. And the relevant hook method definitions. Here we go. So some stuff for updating anchor tags. I've seen some really, really horrible so handle element. Let's see. Okay, some CSS sanitization. And then some interesting. Then post-process also for anchor tags. Okay. The rule of thumb when you're looking for any mXSS vectors is that there are no changes to the sanitized output, no matter how small or irrelevant, can sometimes devalue the use of sanitizer by allowing full XSS. There should be no sanitized changes to the output, no matter how small. There we go, okay. From now onwards, I'm going to talk a lot about DOMPurify internals and mXSS. If you aren't familiar with the mXSS research or the past DOMPurify bypasses, I would highly recommend you to have some solid coverage over those topics. Otherwise, it'll be hard to follow and you won't be able to understand much. So I think a lot of the, the Mizu research is, those are so much worth reading. And unfortunately, really nice browser behavior that allowed those to work has been changed in... I think it made it into Firefox. Yeah, it made it into Firefox. It was good for work though. Whoops. Hey, let's just say if you have stuff that's vulnerable to that, and then the browser stops letting you do that, it's and you're impacted by it, and you can't get it patched. It's a good time. Shout out to Kevin Gravatt. I'm super grateful to have had him by my side when I was learning about mXSS. Just reverse engineered the infamous DOMPurify bypasses, which came out in 2024. He's super talented, at the same time very humble as well. Yeah, Mizu's on his own level, man. He hit me with a Mizu Mind Melter last DEF CON where he was showing me all this stuff, and I'm still like, there's like so much like gadget hunting now for like, JavaScript was a mistake. In Mizu's second blog post, you'll find about cases how DOMPurify can also have some misconfigurations which could allow full bypasses. Our target uses upon sanitize attribute, upon sanitize element, and after sanitize attributes, so we will search for those only. In order to fix the maximum nesting depth bypass vector, DOMPurify decided to go after the entry point, which was the sole reason from where all these bypasses were happening. For mXSS vectors, you will find that to break the context after a namespace confusion, researchers would always smuggle the closing tag of attribute values. There's a very simple example of this. So you'd have there you go. So style, yep, and then look at that. Is this legal? I feel like it encodes these now, right? I don't know. I don't know what the browser does. Wasn't that the fix though, where it'll like encode these as HTML entities or something? I don't know. Because like that's actually in the style context, right? So that's all, these are all just text, and then whoops, the style's closed. Okay, yeah, so maybe it wouldn't. So, but what, you gotta make it think it's an SVG namespace? I don't know. Inside the sanitize attributes method of DOMPurify, which is responsible for sanitizing attributes in their it's a regular expression. The default value safe for XML is true and uses a regular expression based check for attribute value. This is to ensure there could be no closing tag of these elements. All of these tags have some special context like style and could be abused to take advantage of any NS confusion attacks. So this fix single-handedly ensures no more mXSS could be there. From Mizu's blog post, you can see the full POC for the DOMPurify bypass. Wait, I thought his name was Kevin Mizu. I guess like that's, I don't know, maybe it's complicated. I'm not trying to know. Maybe French people have really complicated names. That's French theories. All right. So there we go. So there's, yeah, the repeated. So, yep. The creator behind DOMPurify can be considered the god of XSS, yeah. If you, that guy. If you aren't familiar with his work, would definitely recommend to check out all his past researches and talks. Super insightful if you're someone who loves client-side stuff in browsers. DOMPurify version 3.5.1, there was a quirk related to a pawn sanitize attribute hook in conjunction with the force keep adder of the callbook back hook event. Interesting. So, this is from Mizu research. Yeah. In the example code, you can see current node.nodename.toUppercase. If the value of this is a, meaning it's an anchor tag, the attribute name, which is going to be sanitized, is equal to data-x. Okay. The hook event force keep adder property is set to true. Now what happens in DOMPurify code when hook event.force keep adder as true? It simply calls the continue statement. Okay, so that's like skipping that maybe. With this scenario, the safety checks are completely skipped, reviving the old bypasses again. Actually DOMPurify implemented fixes around nesting depth as well, which was one of the core quirks of the browser which allowed these bypasses, but Mizu along with some other client-side legends were finding bypasses here and there. This is the same story. Whenever there's a new type of DOMPurify bypass, you will see many more similar variants. At last, after playing a game of cat and mouse, a proper fix was to kill the chain itself using the regex check, and the previous added nested depth checks were removed in later versions. Okay. As a fix for this, if the condition check for hook event force keep adder is now placed after the regex check, yeah, so it doesn't skip it. In our target, it had the same misconfiguration, and super luckily, the version used here was 3.5.1. This was a moment to shine. Wow. In this case, the href attribute contained any of these protocols. It would set the force keep adder property to true. Okay, that makes sense. So if you hit those, wow. It means something like this will remain untouched when passing through DOMPurify. Otherwise, the misconfiguration, the href attribute, would have been removed. So you get that through, and haha, oops, we were accidentally. Here we go. So you've got the repeated nesting depth, fun tag. You've got an SVG context. Oh man, nested SVG context. Close one of them, confuse the, okay. Alright. That's, man. So the goal is to get that through in reality after the browser has fun. Uh-oh. But on the target, this didn't work. The on-air attribute was removed. This left me wondering why, if there was another sanitizer in place. I checked again and realized DOMPurify is called one more time. No, not the double DOMPurify. This behavior is actually where DOMPurify is run more than once, assuming it would catch any bypass attempted as well, which were bypassed in the first call. That's really funny. I wonder if that could lead to, like, don't ask how that would lead to problems, but like, that wouldn't make any sense. I don't know. There's been funnier bugs. Also, I like the double DOMPurify Doom. That's a hilarious. Or like I could see things just the code path just being nonsense, and they're just like sanitizing everything everywhere. But worry not, Mizu again has our back. In the first blog, he disclosed all the bypasses. There's a case of Mermaid as well. Mermaid deals with arbitrary HTML, and in order to protect against XSS, they do a similar thing where they call DOMPurify more than once. You can see the bypass here where DOMPurify is called twice. So how many times? Okay, so we're hitting that a bunch, and then we've got our previous looking confusion where, okay, wow, cool. So in the sandbox iframe content, I could see the XSS payload, but here comes the twist. When I clicked on the replay button, the value passed to CKEditor was the sanitized version, so it meant DOMPurify was being called again here. I checked by setting breakpoints, and yeah, it was totally true, going through 2 more iterations when the user clicks on the reply buttons. So in total, there were 4 iterations of DOMPurify sanitize call. Alright, yeah, that does sound like my description of just the code being a mess and sanitizing everything everywhere, because, like, dude, it's going to be so secure. Yeah, how did he pop this? That's crazy. there was a lot of stuff happening in the example code. Things look easy to spot, yeah. But when you're dealing with a real application, they don't appear the same way. Always there will be a lot of irrelevant pieces. It's all about identifying the pattern by reducing the surrounding noise. I didn't want to understand everything and was trying to find a quick win on this male sanitizer. Unfortunate. It seems like there's no quick win to be had. There was a challenge around a very old version of DOMPurify from Sirius. The only thing surprising about this challenge was DOMPurify was called 10 times. Nice. My solution to this was very simple. I just needed to hide my payload and have it mutate after the 10th iteration only. Mizu went overkill for this challenge and came up with a crazy vector. I'm not going to understand how this works. The way he smuggled the broken pieces of the payload half inside the attribute value and half inside the style context. Oh, so when it hits the... Oh, man. Super clever, plus the arrangement of the style tag creativity at its peak. The base idea around this bypass is related to the parsing quirk of mglyph element. I don't know about that. Came up with the following payload to bypass 4 iterations of DOMPurify. Oh my lord. The base idea for this payload is the same as Mizu's, which he used to bypass 2 iterations of DOMPurify. I've only included the same payload one more time inside of the attributes to bypass 4 iterations. What sucks is I'm probably going to need to come back to this research one day. And, like, I mean, it's really good to read it now, but just to look at it and be like, oh, wow. Yeah, builds character. Wow. I'm scared. I'm scared of Sudi. This is powerful, you know? And it's so funny because it's like that this isn't even gonna pop it yet because again, yeah, you have to this is just to be able to get whatever you want into the CKEditor context. As I had a successful bypass now for DOMPurify, I moved on to CKEditor to reverse engineer the POC for the past advisory. Also, if this is who I think it's for, I feel like they're not. I feel like this is a lot of effort for what they'll like. It's not that they'll pay a bad amount for it. It's just like it's just a lot. Reverse engineering the CKEditor end day. So there's the advisory. Potential vulnerability has been discovered in CKEditor. So many of these are such a bummer. The vulnerability allowed to inject malformed HTML content bypassing advanced content filtering mechanism, which could result in executing JavaScript code. An attacker could abuse faulty CDATA content detection. At least this should be so much easier to like reverse than that. Like this is like cutting edge, clever techniques for quirky edge cases of mXSS, and this is just going to be like dumb sanitizer, right? This is like Ultra God Mode Turbo Battle. This should just be like another day in the XSS mines. We'll see, hopefully. Looking into the mail to see how CKEditor is implemented, I could see the first argument is supposed to be the element selector and the second argument contains the JSON config. One thing to note here was it had this extra content allowed style, which allowed style elements, otherwise in default config this is removed. Based on the advisory, it was first fixed in 4.24.0 LTS, so we will start by diffing the previous version. Easily found the commit related to the fix, CDATA parsing logic. I set up some breakpoints around it and started playing with the code changes. The parsing for CDATA alone is happening here. Riotech had a nice write-up around CDATA parsing logic, which allowed him to bypass DOMPurify. Directly testing it on a local setup was much easier than focusing too much on the source, as the advisory comments had some mentioning around style tag. I tried playing around embedding CDATA blocks inside of it. My focus was if I can hide the closing style tag inside of CDATA, which will allow me to hide a payload that gets missed by the CKEditor sanitizer, but when parsed by the browser, the hidden payload comes into action. So you get something through where, in one context, what are we hoping for? By setting a breakpoint on this line, oh lord. By setting a breakpoint on this line, this.on CDATA, CDATA.join, I could see what all is parsed as CDATA block in the screenshot. You can see the array H containing all the parts. Yes. Where's H? Is he doing this with... Huh. Okay. So, something like that. The fixed version, the input produces a different output. Ooh, nice. So what happened here? Let me explain. First, let's see how the same gets parsed by the browser. So, look at that DOM tree we have. Hey, look, that's something I want in my DOM tree. That's pretty nice. This is what the browser sees. New line denoted at the end of each element. I already explained the style element is the starting of the blog post. This is what CKEditor HTML parser sees when parsing CDATA block. CKEditor doesn't take into account the closing style tag, it just looks for the closing CDATA block. And consumes everything that comes in between. That's, okay, so that's where the magic lives. This creates a parser discrepancy between the CKEditor HTML parser and the browser parsing. So it's another mXSS. That's really funny. The core fundamental of any mutation. So wait, the double mXSS? An mXSS to smuggle through an mXSS payload. Man, this is insane. This is actually insane. What? Alright, I see why he was so hype about this in the intro, yeah. This creates a parser discrepancy between CKEditor HTML parsers and how the browser parses the same HTML. The core fundamental of any mutation bug is to find exactly this kind of discrepancy. The image tag, which CKEditor thinks is harmless, CDATA content sitting inside style, will actually be rendered as an active HTML by the browser. We have our CKEditor XSS now. Wow, man. The final chain. We're getting closer to our goal. To summarize, we tested out our bypass locally for DOMPurify, which works with bypassing 4 iterations of DOMPurify sanitize, plus we now have the CKEditor end APOC. Now we just need to place the CKEditor payload inside the DOMPurify bypass. Will it be so simple? Please just work. The only change I made was here inside the attribute value. You can see it contains the CKEditor payload, which I just demonstrated above. Yeah. This allows me to get XSS in the local environment setup. Upon testing the same vector in the redacted mail application, it didn't work. The payload was breaking here and there. That's meant my local setup is not exactly the same as what's on the target. Oh man. Investigated further and concluded they were doing something like this. I was dealing with minified.js, so it was hell to figure out what exactly they were doing. So they have clean, and then okay, they're that's so nasty. That's I spent a few more days on fixing the payload. It was getting broken at one point or another, or there was something more going on behind the scenes as well, as nothing was working for him. How did he actually pop this? This is way too challenging. I decided to reshift my goals and asked myself, can I smuggle the same CKEditor payload without using the nested DOMPurify bypass? I thought if I can find some mutation for the CDATA payload where DOMPurify sees it differently, considers it safe compared to CKEditor, which is a different parsing rule. Now that would be clever, right? Because then instead of like having to nest your bypasses, you're just like, yeah, this is like a totally chill thing, because if you, wait, it needs to not be chill though, because it needs to hit the browser and not be chill. Or maybe you can get the CKEditor to mutate it and make it no more chill. That'd be powerful. So you've got some stuff. DOMPurify has the following code to deal around with this, where upon detecting any possible starting or closing tags, it would remove the element itself. But worry not, again, luck is on our side. The OpenCDATA starting block gets passed through the regex test easily without triggering any alarms. Same works locally, but in the target you can see the difference. The first iteration itself, the content inside of the style element is removed. The culprit for this was upon sanitize element hook method, which inside uses a CSS sanitizer to ensure users can't include any sort of arbitrary CSS in mails. The CSS sanitizer is a full-blown CSS parser which goes through all the CSS rules and their respective values. Bypassing this was very easy. I just needed to include the payload inside of a CSS rule. This goes as it is through DOMPurify. That makes sense. Coming back to the original payload for CKEditor, oh man. For 1, I can see. For 3, the CSS sanitizer will convert to style. For 2, DOMPurify parser will easily see the image on error vector. Oh man, that's... Remember that DOMPurify doesn't allow you to include any tags inside of it. Regex checks, so the only possible way for me to hide this payload would be inside the attribute value. Otherwise, it will always be sanitized. The same for the closing style. I can't include it anywhere else. The only possible place where I can put an extra closing style tag is inside the attribute value. That too is only because of the hooks, force keep adder, misconfiguration. Yeah. So this was the payload I came up with to bypass both DOMPurify and CKEditor. The payload appears safe, so DOMPurify lets it pass, but when parsed by CKEditor, it's a different story. DOMPurify sees... Okay. And this is how it gets parsed by CKEditor. Finally, some tweaks were needed to make it work on the real target, and this is how it ended up looking. This is for how he was feeling. Yeah, a lot of screaming. When the DOMPurify bypasses came out, mXSS was something which I was really scared of and couldn't really wrap my head around. Yeah. If you call yourself a client-side lover, mXSS is something you should have a really good grasp on, so I had no choice but to get good at it. Nah, man, they killed mXSS. Don't worry, man. Trust me, bro. Yeah, I wish I was better at thinking about it. And, oh well. When I need it, you know? I spent way too long on DOMPurify in order to reverse engineer the POC IIRC. The DOMPurify bypasses were only disclosed publicly a year after the advisory came out. I still remember I used to debug DOMPurify source line by line to understand how it works, reading RFCs, reading all previous mXSS related findings, trying to find those on your own just to get a feel for how they were discovered. If I hadn't spent the time on mXSS, I would have never found this XSS bug in the mail application. mXSS payloads aren't something which you can build blindly unless you know what you're doing. Yeah, you need to understanding of basics, how HTML is parsed and serialized from the ground up, yeah, and different namespaces, and so those quirks about elements that change how it's the absolute best content out there in the world for anybody who wants to get started with XSS. Michael Bentowski explains things so well. I watched this video like 2 to 3 times. Video from Live Overflow still gives me goosebumps. I got my final hint for the DOMPurify by watching Sirius's video. Only otherwise, I don't think I would have been able to come up with a POC in time before the public disclosures were made. Wow. I'm gonna pause and like think about all this. Before wrapping up the blog post, mXSS is cool, right? But guess what? The above payloads you saw won't actually work now. Okay, I thought so. That due to a spec change which is adopted by all major browsers. Yep. Spec was pushed by none other than SecurityMB, the same person who once started all this by finding those DOMPurify bypasses in the early era, put a nail in the coffin. If you want to test, hey, it's interesting. It's an interesting defense mechanism. If you want to test the payloads yourself, they will work on the latest version of Firefox and Chromium. Due to the above spec changes, you'll need to disable that feature for Chrome, and then in Firefox set that. Yeah, so okay, I thought those that it where's just like a plain, man, this is insane. So I think I know the target, but I'm gonna go check it now, I guess, and see if it uses the same stack. So there we go. Yeah. So these would be encoded. Well, those would those be? I don't even know. Right. That's like the fundamental. Or maybe it's in the more complex. Top 10 people that doesn't really know how all of the mXSS tricks work. Like, I do not know all the mXSS. I don't even know. If I had to make up an mXSS trick, I would be like, well, I didn't close it, but then it added the closing tag for me, and the parser was like, oh, I actually need to do that. I can't. I've a very funny bug that involves HTML parsing from a remote server that I have some theories on how to do something useful with that involve, we'll call it MSSRF. Oh, Lord. All right, so... Yes, research review. Insane write-up. We're back. Finally a good blog post. Or good research. Amazing. Insane chain. Can't believe he actually popped it. I'm guessing the target. Let's see. What if I had to guess? If the target is what I think it is. Let's just say they did like a 10K bounty. That's my theory. I have no idea. Let's see. Rating. I gotta rate this. I rate this closing style tag out of 10. because, man, coming up with the way to do like n-level DOMPurify bypass, like, or to take your DOMPurify bypass and then have it survive n levels, very cool. Further research, I mean, this is crazy. Like just the level of effort that went into popping the target. I think that's a really good example of just like why this worked and how this can be applied generally to BB. Just like the level of, number one, just like taking it apart and understanding how it actually worked, getting those like local test instances, debugging it and knowing what's going on, and then being able to like work through each piece one step at a time with faith that you'll be able to solve the next challenge you get to is, this is insane. I think that I'm sure there will be novel ideas on how to cause fun like parser differentials with funny things that the browser does to fix your HTML. So I anticipate plenty more mXSS in the future. I think looking for novel mXSS techniques now that the really, really useful one here is patch. I think this guy commented about something about changing some behavior that, I don't know, man. I'm not caught up on all, like, I don't even know about an mglyph, man. Should I go figure it out? Probably. I have some funny ideas. But this is an insane dose of extreme hackage. So I think what my takeaway is just the level of like dedication and devotion to like pushing it one step further and like pushing through and getting the final exploit around the corner and popping the target. Insane, unreal, very good write-up. You should follow Sudi on Twitter or X or whatever, and yeah, he's dropping some really good stuff here. This is amazing. Thanks for watching.